So when we are insulin sensitive, we are down regulating de novo lipogenesis, or the creation of fat from carbohydrate. Okay, so that would be this pathway right here. So buildup of acetyl-CoA isn't just from carbohydrate either. From pyruvate contributing to this acetyl-CoA, and this fat going into and causing fatty liver disease. Acetyl-CoA is also contributed from dietary fat. So that's something that's really important to keep in mind, that fatty acids contribute to acetyl-CoA as well. So is it a buildup of sugar in the diet, or are we dealing with a buildup of fat? You know, this is insulin resistance that is causing this problem. Okay.
This gets made into fat. So that's why eating processed food with a lot of high fructose corn syrup tends to produce a fatty liver. And fatty liver is super.
Now, Dr. Rogers just said processed food with high fructose corn syrup. Processed food is generally high fat food. So when you put high fat with the carbohydrate, you are creating a situation where that sugar cannot be metabolized properly. Okay, so you're creating a level of insulin resistance, which is going to lead to impaired sugar tolerance.
Super common. I would say the majority of Americans over 30 have a fatty liver. I see them all day long for incidental reasons. Patient comes for totally different reasons, but I somehow get a look at the liver and it's a fatty liver. That happens all the time. And fatty liver basically means diabetes of the liver.
And I can bet that the majority of people that Dr. Rogers are seeing are not folks that are eating a low-fat diet, in particular because we have been conditioned over the last 3 decades to believe that carbohydrates are bad, but people inherently still consume them because we are driven to consume glucose for our energy production, right? So intuitively we go for it, but a lot of times it comes with fat. And then the more people restrict sugar in their diet, the more fat they consume as a byproduct of that. So fatty liver disease is caused by too much fat in the diet, being in gluconeogenesis for too long, which programs the body to favor de novo lipogenesis, or the creation of fat from carbohydrate.
Okay, so you're pre-diabetic or diabetic if you got a fatty liver. Okay.
And what have we learned about diabetes, right? From Percival Hemsworth, is that sugar tolerance is impaired by starvation, which would be glucose starvation, or the taking of diets with a high content of fat, while it is improved by taking diets containing an excess of carbohydrate. So we're just tying it all together, right? So Peter Rogers is pulling a McDougall here, where he is contradicting himself in a few ways, where he's saying fructose is the problem, but the patients that I'm seeing with fatty liver disease also have insulin resistance, and insulin resistance isn't caused by sugar, it's caused by dietary fat. So we're kind of missing how that would create this condition of favoring de novo lipogenesis over controlling for fat intake in the diet.
So you need to know, this is real important, that a byproduct of fructose metabolism in the liver is to produce uric acid. And we're going to talk a lot more about that, and that's going to have a big deal. So they're getting fat, they're getting fatty liver, that's predisposing them to worsening diabetes, and they're making lots of uric acid, which is going to make them hypertensive and cause some other problems. Okay, so just want to talk a little bit more about the...
Okay, I want to now go into my little section on how I kind of debated Peter Rogers on this topic using this study here. And this is from from PubMed. So this is peer-reviewed clinical research data on sucrose, high fructose corn syrup, and fructose, their metabolism and potential health effects. What do we really know?
And it basically looks at fructose, glucose, high fructose corn syrup, and sucrose, and how they relate to obesity and adverse health outcomes. And the findings of this study are very interesting. So I'm just going to go down to, here's fructose metabolism, just like Dr. Rogers was talking about, and how this is the pathway here, this triose phosphate here. This is how it ends up as a getting shipped into fat, right? Yeah. Through this pathway here. But fructose will also get funneled into the ATP cycle as well.
So in this study, we've got a little bit of a different chart going on here in comparison to Dr. Rogers' chart. So we've got glucose metabolism here, we've got fructose metabolism, and we've got protein and amino acids, okay? So the reason why these three molecules are being featured is because they can all feed into the TCA cycle, okay? Protein and amino acids, of course, are going to be signaled for glucose, or really it's pyruvate donation when we turn on gluconeogenesis. So we've got glucose that can, feed in this way to the TCA cycle for ATP generation. We've got fructose that can feed in that way as well. Here's the pathway for fructose to turn into triglyceride. So we've got the fat generation here, but again, this is regulated based on our insulin sensitivity. Okay, so de novo lipogenesis is going to turn this pathway on or favor this pathway if we are insulin resistant. You also have here glycogen that can donate glucose. And then you've also have fatty acids over here where they can contribute to the acetyl-CoA for the TCA cycle, or they can be converted into triglyceride as well and be stored as body fat. So they have two fates here. And this is why when I suggest that if you want to burn more body fat, you need to maintain a dietary fat deficit, because you always have fatty acids that are donating to the TCA cycle, donating the acetyl-CoA, and you also need to drive the TCA cycle via glucose or fructose, which can be converted into pyruvate as well. So you need this pyruvate to be contributing to oxaloacetate in order to drive the TCA cycle. I hope it's not too much. I go over all of this in more detail in my coaching program. Link for that is in the description of this video. But all you need to understand here is that fructose and glucose being converted into fat, stored body fat, is turned on. So it's upregulated when we are insulin resistant, where there is a desire for the body to create body fat because we were just in an energy famine situation. And that's what happens when we're insulin resistant, is we're not able to take the sugars that we consume, the carbohydrate that we consume, and convert it into ATP efficiently. Okay, there's some kind of derailer in this process, and oftentimes it's insulin's ability to get glucose into the cells. So when you decrease your fat intake and increase your carb intake, then you are able to run everything much smoothly, increase your metabolic rates, increase your ability to turn what you eat into fuel, and then also to burn body fat. So I hope that this all makes sense.
the TCA cycle, I'm sorry, through producing pyruvate. So I wonder if the information that's found about fructose causing fatty liver and all these other health outcomes like the generation of uric acid, for example, is done on people who consume a high fat diet or a diet that's not controlled for fat while consuming fructose, because the findings of this study are really interesting. This says here, even in settings of extreme carbohydrate overload, only a small percentage of carbohydrate is converted into fat in the process of de novo lipogenesis. So in their experiment, they fed people 1,500 extra calories in excess of carbohydrates, and only 3.3 grams of fat was generated here. And they did use healthy individuals.
So the key word there was they fed these individuals 1,500 extra calories in excess carbohydrate, and they were only able to generate 3.3 grams of fat. Okay, and dietary fat was not being controlled for. So what does the dietetic factors influencing the glucose tolerance and the activity of insulin by Percival Himsworth tell us about glucose metabolism and insulin sensitivity? It's that sugar tolerance is impaired by starvation or the taking of diets with a high content of fat, while it is improved. Sugar tolerance is improved by taking diets containing an excess of carbohydrate. So you're seeing it right there, okay, where you're overfeeding these people and not controlling for dietary fat intake, and you improved their insulin sensitivity, okay, and decrease their ability to turn carbohydrate into fats. So this process of consuming more carbohydrates turns off de novo lipogenesis. And when you're controlling for fat intake, you are not going to be creating fat that is going to be stored in your body. Now, something that I do get questions about a lot is if you're not eating fat, how are you going to, have the structural material you need to repair your cells and things like that? The thing is we can make fat from carbohydrate. We can make what we need from eating a low fat diet. Now, it's never a no fat diet because you're still going to be getting, around 10 grams of fat a day eating an overt fat-free diet. So you can turn those essential fatty acids, which is going to be what the majority of those are if you're eating fruits, greens, and starches, as well as, some other fatty acids, but you'll be using those for, said processes of repair and maintenance. Okay. And then whatever else you need, we can make from other materials that you're taking into your diet. Okay. Cholesterol, things like that. So it's a non-issue.
So we're not talking about starved people. So and that's something that's important to register too, because the majority of people that I work with are coming to me from a calorie restrictive, low carb background. So this really doesn't apply to them in terms of like how de novo lipogenesis will be ramped up in cases of people coming from starvation mode to a high carb diet.
And why is that? Because insulin resistance is turned on. So it's going to be favoring de novo lipogenesis. But when you're in a fed state, okay, and carbohydrate hasn't been restricted from your diet, and you add a bunch of carbohydrate onto your diet, you're not going to be turning a whole lot of that into fat at all. And then, you're also going to be able to burn more fatty acids via oxidation in the TCA cycle as well.
So I just want to go down to the conclusions here. And, this is open to interpretation, but this is basically what they found, is that Fructose consumption at 25% of calories compared with glucose at 25% of calories acutely increased uric acid profiles. However, research in our lab comparing high fructose corn syrup with sucrose yielded identical responses and no increases in acute levels of uric acid in either normal weight or obese women were found. And then it also says down here whether fructose consumption results in increased risk factors for metabolic syndrome also remains in dispute. And what was the other one? Yeah, here. Studies exploring whether fatty infiltration of the liver or muscle occurs in response to fructose consumption have produced disparate findings. And I think the reason why this study is all over the place, where they're finding certain people have higher uric acid profiles, certain people don't have any, changes in uric acid or fatty liver, is all comes down to like how that individual is metabolizing the fructose. Also, what their metabolic rate is like, how active they are, how much dietary fat they're consuming. So there's so many,
whether they're insulin resistant or not.
Questions. And whenever I go through like studies like this, I'm always asking myself, like, what was the fat intake like? Because that will really vary what the results are going to be as well as like what kind of diet was this person eating previously. That's going to have an effect on it. But in general, at least in my personal experience and the experience that I work with my clients, who I can get them on a high carb, low fat diet and I can keep them on it long term, they all end up experiencing improved blood work, including lipid profiles, triglyceride levels, liver enzymes, and that's
lowered uric acid levels, improved insulin sensitivity.
Eating a high, sugar, high fruit, high carbohydrate diet with the addition of, a high carb, low fat diet with the addition of refined sugars. And I think the reason that happens, and it's something I've experienced with myself too, eating a high carb, low fat diet long term with the addition of, sugar, high fructose corn syrup on occasion, things like that, is because I'm not experiencing this like spillover effect. My appetite is regulated, so I'm not, converting the fructose into the fat and increasing my liver, and creating fatty liver.
So what I'm referencing here is hyperphagia. And hyperphagia is a byproduct of low leptin levels, which occur when we don't consume enough carbohydrates. So rapid weight gain and fat storage, upregulation of de novo lipogenesis, insulin resistance, elevated cortisol, all this is related to an insufficient carbohydrate intake. So after you end your famine period, your appetite is ramped up. So that's hyperphagia, increased appetite. And the purpose is so that you can restore weight, store fat, so that you can survive your next famine, because that's what you've told your body that it's dealing with, is a famine situation. So in order to turn off de novo lipogenesis, maintain insulin sensitivity and normal leptin levels, which leptin is our long-term hunger hormone. Basically, it senses whether there is sufficient carbohydrate around or there isn't, okay? And it will encourage us to eat the house down or eat and then be done, depending on carbohydrate availability. So if you want to not experience hyperphagia, all you need to do is eat sufficient amounts of carbohydrate. So this is all related to insulin sensitivity. Elevated cortisol drives insulin resistance. Elevated cortisol gets signaled from a dietary need for carbohydrate. So when people are stressed out and they eat a bunch of sugary junk food, chocolate, donuts, cakes, cookies, whatever, they are lowering their cortisol due to the sugar content of the food, but they are taking a lot of fat, okay, with that, which gets, goes into storage and then encourages insulin resistance due to the fat intake. So that also has been researched. And let's see if I can pull that up real quick. Sugar and cortisol lowering effects. I have referenced this study. There we go, right here. So real world intake of dietary sugars is associated with reduced cortisol reactivity following an acute physiological stressor. Sugar intake significantly predicted a weaker cortisol response following the cold pressor test controlling for BMI and gender, revealing an inhibitory effect of calorie-dense diets on cortisol reactivity to stress. As the consumption of sugar rose, individuals had lower post-stressor cortisol levels, a smaller rate of increase in cortisol 20 and 35 minutes after the CPT, a lower cortisol peak, and an overall weaker quadratic effect. So is sugar really the problem here, or is it the fat that comes with the diet? I mean, I don't know anyone other than the people that I work with personally and maybe, a couple individuals on social media who are promoting a high carb, low fat diet. Eat the sugar, but keep the diet low in fat so that we can avoid all of the health conditions that get associated with sugar consumption, but are really coming from the fact that dietary fat intake is not being controlled for. So that is it pretty much for today's video. I am going to go back to Dr. Rogers' video here for just a second.
Sensitivity, but we're going to get into a couple more details here, and there's a couple things that become quite interesting. This is a subject that people get pretty excited about, and it's a much more complicated subject than it seems at first. Why is it that so many of these fruitarians are really skinny? So this is Michael.
Why is it that fruitarians are really skinny? And a fruitarian is somebody who eats a fruit-based diet. Okay, so it's going to be a high carb diet. It's not always low fat, but in this case with Michael Arnstein, he does consume a high carb, low fat diet.
Arnstein, he's an ultra marathoner, and he's a fruitarian. He moved to Hawaii many years.
Okay, and here's another one.
And there's other persons like Kipchoge is that famous marathon runner, and he talks about, putting lots of sugar into his iced tea drink, and he says that gives him more endurance to run his marathon race, for example.
So he's going through people who eat a high sugar diet, and he asks too, what comes first, the chicken or the egg? In order to get to this level of leanness and the fitness level, this is a really old picture of Harley Johnstone, aka Durian Rider, who still looks just as lean. I'll bring him up in a second here. In order to get to this level of leanness, you need to have exceptional insulin sensitivity. How do you build that? Okay, are you just born with it? No. You build insulin sensitivity by putting the carbohydrates in first. Again, referencing the dietetic factors influencing the glucose tolerance and the activity of insulin. Sugar tolerance is improved. So this is insulin sensitivity by a diet containing an excess of carbohydrate, low in fat, excess carbs, okay, increases the metabolic rate, increases the your ability to produce energy, increases your ability to burn fat, because now that you've got all this energy, okay, you can burn body fat. And because you're not taking in any fat, you're able to oxidize more of your stored body fat. And because you're taking in all this energy now and you have all this energy to do stuff and you focus on getting fitter, okay, you are going to increase your VO2 max. Increasing your VO2 max increases your ability to uptake oxygen. Okay, so this is a recent clip of Harley Johnstone. He is almost 50 now, super duper lean. Okay, super fit as well, runs like an 18-minute 5K, and he is in his late 40s. This is Get Fit with Natasha. She is, I believe, 26, 27, lean bean, super fit gal. Okay, let's bring up Freely the Banana Girl. She's also in her mid 40s, super fit gal. Okay. I have similar results to this. I showed you guys at the beginning of my videos because a high carbohydrate, low fat diet produces this kind of results long term. And I just explained why. So anyways, I think that's it for today's video. You know, this is kind of Peter Rogers contradicting himself, where he's showing these super lean guys, and saying, well, you know, they can be lean because they're doing all this exercise, right? Well, you got to put the sugar in order to do the exercise, though. And I've learned this firsthand because I've always been like leery, oh, should I like add sugar to my diet? Like, how's it going to make me feel? Until I've gotten to the point where I needed more calories in order to just keep up with my everyday life, to run my business, to get fit, to be a good mom, to take care of my house. And so I was like, okay, let's start adding the sugar in and see what happens. And boom, increased insulin sensitivity, leaner, getting fitter, just happier in general. Some of you commented on my last live that you were impressed with my ability to manage my son at the same time that I was filming. And that's because I'm carbed up. Okay. Put the carbs in, get the energy out, fuel that metabolism. So that's it for today's video. Thank you so much for tuning in. Leave any comments or questions down below. I will leave links for all the studies that I referenced in the description of this video. You can also find access to my coaching program there. It's available on my website, www.nutritionbyvictoria.com. My coaching group is also still on sale until the end of February as my Valentine's gift for you guys. So please take advantage. It is a Q&A, a limited Q&A, lifetime membership, private Facebook group. I've got questions coming in all day, every day that are really exceptional and will help you on your journey to have my support and also the support of other people who are working towards the same goals. Okay, take it easy, folks, and I will see you guys next time. Leave a comment also what you'd like me to talk about next. All right, bye, guys.